I'm going to talk about John Bardeen, an American physicist born on the 23rd of May 1908 in Madison, Wisconsin. He was awarded the Nobel Prize twice, the first time in 1956, and in collaboration with Brattain and Shockley due to the transistor.
On the 60th anniversary of the death of Alfred Nobel, the prizes bearing his name are awarded at Stockholm, Sweden. The presentations are made by King Gustav Adolf of Sweden in a brilliant setting. Dr. William Shockley is one of 3 Americans sharing the Physics Award for research which produced the transistor. Dr. John Bardeen shares the prize, which includes a check for $38,700. The third colleague is Dr. Walter Hauser Brattain.
And in 1972 with Schrieffer and Cooper launching their VCS theory. He was the second son of Dr. Charles Russell Bardeen, Dean of the University of Wisconsin Medical School, and Althea Harmer Bardeen, a well-educated woman who studied art and design at the Pratt Institute in Brooklyn. At the age of 12, Bardeen's mother became ill. She was suffering from cancer, and in order to help his children, Charles downplayed the seriousness of her illness. John Bardeen then studied at the University of Wisconsin to get his master's degree in electrical engineering, career he loved as it contained maths he liked and had also good job prospects. After having worked for a short period of time at Gulf Oil Company as a geophysicist, he went to Princeton to get his PhD in mathematical physics. It was there where he first got involved with studies of metals. At that time, scientists like Eugene Wigner and Friedrich Seitz were developing new theories of quantum mechanics to help understand how semiconductors worked. He finished his doctoral thesis in 1935. He married Jane Maxwell in 1938, a biologist who worked as a teacher at a girls' high school near Boston. William Shockley, another physicist John Bardeen had already met before in Massachusetts, was leading a new research group at Bell Laboratories, and he got informed about Bardeen's skills. This led to his family's move to New Jersey. There, he was introduced to Walter Brattain, and they worked together carrying out lots of experiments and weaving theories to explain results. In 1947, Shockley asked himself why an amplifier he had devised didn't work. Brattain and Bardeen helped him solve this task. His amplifier contained at its heart a crystal of silicon. They would end up using germanium instead. Remembering some of the quantum mechanics he had used at the time he worked with semiconductors in 1930, he could finally come up with the main problem. Electrons behave differently in each part of the metal. It had been assumed that electrical current traveled through all parts of the germanium in a similar way. Taking this into account, on the 23rd of December 1947, Brattain and Bardeen built the first point-contact transistor. Let's now briefly explain what is it about. A transistor is a semiconductor device used to amplify and switch electronic signals. The control output power can be much more than the controlling input one, and this provides amplification of a signal. Nowadays, most of the transistors are seen in integrated circuits. The transistor is the fundamental building block of modern electronic devices.
The transistor is like an electronic valve that can be used as an amplifier or a switch. It can control a large current flowing through 2 regions of a semiconductor crystal, like silicon, with a small current applied to a middle region. There are many kinds of transistors. Typical is the bipolar, which has 3 layers: an input layer, a control layer, and an output layer. The layers are either N-type material, which conducts negative charges, or P-type material, which conducts positive charges. The layers are arranged like a sandwich in an NPN or PNP configuration. The individual layers are formed by treating pure silicon with trace amounts of impurities. Adding boron will create N-type material, phosphorus P-type material. N-type material will have a surplus of electrons, whereas P-type material will have a lack. P-type material has a surplus of electron holes and is therefore positive. The silicon crystal is called a semiconductor because it will only conduct a small amount of current unless a change occurs at the junctions of the layers. In bipolar transistors, the input layer is called the emitter, the control layer the base, and the output layer the collector. When a current is applied to the emitter of an NPN transistor, electrons readily cross over to the p-type base, filling the electron holes. But when these holes are filled, the resulting negative charge repels further electrons that would come from the emitter. The transistor does not conduct. But when a small positive current is applied to the base, it will produce additional holes that will, in turn, allow more electrons to come from the emitter and pass through the base to the collector. Adding more or fewer holes into the base with positive current allows more or less current flow from emitter to collector, like a throttle controlling the speed of an engine. Because the emitter to collector current flow is up to several hundred times greater than the emitter to base current, the transistor makes a powerful amplifier.
But the idea of the transistor had emerged some years before. It was physicist Lilienfeld in 1925 who first filed the first patent for a transistor, describing a device similar to a field effect transistor. However, he did not publish any research articles about his device. In 1934, German inventor Oskar Hill patented a similar device. And in 1942, Herbert Matre experimented with diodes while working on a detector for a Doppler radar system. He was not able to explain many effects by two independently operating diodes, and this way he formed the basic idea for later Bardeen and Brateen's point-contact transistor. Nowadays, as explained before, the transistor can be found in almost every electronic device that surrounds us in our daily lives. It is considered to be one of the greatest inventions of the 20th century. Its low cost, flexibility, and reliability have made it very useful in lots of electronic objects we normally use, such as MP3s, iPods, washing machines, printers, X-ray systems, and so on. After this invention, Bardeen would go on to focus on superconductivity, what would bring him a second Nobel Prize with his BCS theory, working with Cooper and Schrieffer in 1972, which was based on the fact that extremely cold metals are able to conduct electricity very efficiently. This second Nobel Prize made him become the only person in history to have received 2 Nobel Prizes in physics. John Bardeen lived in Urbana for the last years of his life, researching and playing his favorite sport, golf. He died in 1991, at the age of 82.